the program I'll be mainly focusing on today is our Biomedical Technician Training program, or BTT program. There we go. We also developed a life science innovation course in partnership with LaSalle University. And then our new program with Cheyney University, the nation's first historically Black college or university. Both our Biomedical Technician Training program and our program with Cheyney University serve as pre-apprenticeship training that leads into our Biomedical Research Technician Apprenticeship. For the graduate student side, we are located right on the campus of the University of Pennsylvania. So we teach 2 graduate courses for the University of Pennsylvania. One is a Wistar cancer biology course, and the other is a popular vaccine and immune therapy course. We have students from both the University of Pennsylvania and from nearby Drexel University who can choose to do their thesis projects with our faculty at Wistar. And then we also have a Ph.D. program in cancer biology with the University of the Sciences. And then again, even though we were in the midst of a pandemic, we were able to launch a new Ph.D. program in collaboration with the first university in the Western world, the University of Bologna in Italy. Our biggest group of trainees at the Wistar Institute are actually our postdoctoral fellows who come to Wistar, to extend their scientific training before carving out their independent careers. So as I said, I really want to focus on the Biomedical Technician Training Program, which was developed as a partnership with the Community College of Philadelphia in 2000 by Dr. Bill Werner. Bill is a professor emeritus and actually just retired as Director of Outreach Education and Technology Training at the end of 2021 after 45 years of service at the Wistar Institute. So Dr. Werner ran his own laboratory, then ran a core facility, and started this biomedical technician training program as really a workforce development program to stabilize the workforce at the Wistar Institute. So as we know, it's very common for students with bachelor's degrees to take positions as laboratory technicians or research assistants as an intermediate position. So they would stay, on average between 1 and 3 years. The scientists at Wistar would spend a lot of time training them, but then they would often go on to graduate programs or health professional programs. So Dr. Werner had done his postdoctoral training in a junior faculty position in Scotland, and he knew in Europe there was more of a model for individuals with less than a bachelor's degree to take on those laboratory technician and research assistant positions and spend a longer amount of time in those positions. So he reached out to Community College of Philadelphia to be a partner, and this is going on year 23 now. So the program under Dr. Werner ran essentially the same way from 2000 to 2019. It was a 2-summer program. So during the early summer session, students participated in 7 days of laboratory orientation. Like many community colleges, the Community College of Philadelphia is closed on Fridays in the summer. So we knew that students wouldn't be taking classes on Fridays. And so we had them for those 7 Fridays of the early summer semester in a lab at Wistar. And then they did 2 3.5-week lab experiences where they were applying their skills learned in the laboratory orientation and also being introduced to the diversity of biomedical research. And then students would usually return the following summer to complete a 12-week lab internship in one of those 2 labs where they did their first summer lab experiences. So we had strong outcomes. So over those years, we had 160 students complete the program, 77% completion rate, including 52% underrepresented minorities and over 71% female. Even though it was originally designed as a workforce development program, 64% of the individuals who completed the Biomedical Technician Training program continued their education at CCP, with many going on to transfer institutions and earning those bachelor's degrees, and even some continuing on to master's and PhD programs, as well as a number going into PharmD programs. 46% of our graduates did obtain laboratory positions within a year. And you'll notice that 64% and 46% add up to greater than 100%. And that we really think has always been the strength of our program. You know, we know that a lot of community college students and really a lot of undergraduates now at four-year institutions need to be working while they continue their education. So, you know, I think a strength of our program has been that it has allowed graduates to be able to obtain positions, right, in the field that they want to go into. So they're working in a lab part-time or continuing as a full-time student, or vice versa, working in a lab full-time and continuing their education on a part-time basis. So we all know what happened in 2020. So even though we were able to individually work with students and labs to have students who were in the middle of the program complete their 12-week lab internships, we weren't able to start a new cohort in 2020. And in retrospect, this actually turned out to be a good time for us, because we were able to take a step back and you know, look at our data and really rethink how we were doing things. So of course, I had interviewed and selected a new cohort who thought they were starting the program in May of 2020 and would finish it in August 2021. And I also had, you know, this strong feeling that I wanted to keep that promise to the students, and you know, come up with a program that would still allow them to finish in that same timeline in August of 2021. And then we started thinking that, you know, really a lot of the attrition that we saw were between the first and second summers of the program. And it wasn't always because it wasn't a good outcome. You know, sometimes one summer of that hands-on training was enough for students to be hired in a laboratory position. And other times they transferred into a program or a school where they didn't have a second summer to be able to come back for the internship. So we thought that the one summer program might be a better fit for community college students. And so with funding from GlaxoSmithKline's Philadelphia STEM Equity Collective, we were able to pilot an accelerated version of our biomedical technician training program this past summer. So instead of doing those 7 Fridays, we actually gained 2 days of training. We did 2 weeks, Monday through Friday, all day, as a 2-week hands-on laboratory orientation. And then the students did 2 6-week lab experiences, one in an academic lab and one in an industry lab. So this is me with our academic coordinator from the Community College of Philadelphia, Dr. Dominic Salerno, who's also a co-PI on the NSF grant, as well as I think Dr. Maggie Bryans is also in our audience today. She's another co-PI on this grant. But Dominic and I were so pleased with the outcomes. So we had 100% completion rate this summer. 11 out of 12 of the students continued their education this past fall semester. And, you know, even though it's only been 5 months since the end of the program, we have 5 out of 12, or 41.7%, working in laboratory positions, including 1 student who has continued on into our biomedical research technician apprenticeship. So we also, you know, because this was new, wanted to make sure that the students were really learning what we wanted them to learn with a shortened amount of time. So we developed an assessment tool for our mentors who were working in those academic and industry labs to use to assess the students. And you can see they had, you know, pretty high ratings. So, you know, on a 0 to 5 scale, All of the ratings were average ratings amongst all the students were between a 4 and a 5 for things like follows and practices safe laboratory procedures, uses reagents and lab equipment safely and appropriately, follows and understands protocols and SOPs, calculates and prepares solutions correctly, plans and sets up experiments properly, performs experiments using technical skills, applies sterile technique in practice, collects and records data, maintains laboratory notebook, and begins to start analyzing data and troubleshooting, and then communicating results and demonstrating professionalism. So we were really pleased with these ratings. And then we also use an assessment tool for the students to assess their own gains from the program this summer. So the SALG, Student Assessment of Their Learning Gains, URSA, Undergraduate Research Student Self-Assessment, was a tool published by Weston and Larson in 2015. We had really nice outcomes here, where 60% of students strongly agreed, right, that doing research confirmed their interest in the field of study and clarified which field of study they wanted to pursue, and prepared them for graduate school. And even stronger, over 70% strongly agreed that the research experience prepared them for advanced coursework or thesis work. And then, again, nice to see, since this was developed as a workforce development program, that even though only 41% of students are currently working in laboratory positions, that more than 80% of participants who responded to the survey strongly agreed that this experience prepared them for a job. So we are really excited. We started work on the NSF project grant, but we will have our first cohort of students supported under this grant this coming summer in 2022. So in terms of program expansion, we are going from 12 students to 21 students in the cohort over the next 3 summers. And we are expanding from just students coming from Community College of Philadelphia to, in our first year, students also being recruited from Montgomery County Community College. And then in year 2, students being recruited from Bucks County Community College, as well as Camden County College, which gives us a couple of challenges of crossing state lines into New Jersey. And then in year 3 of the grant to recruit students also from Delaware County Community College, which also serves Chester County. So by the end of the grant, we should have really expanded more regionally to serve the workforce needs in this area. So the curriculum evolution has been my favorite part of the project that we've done a lot of work on already. And so we always incorporated many of the skills listed on the right, but we were doing so in the old hands-on laboratory orientation as really standalone lab exercises. And I was really interested in developing a CURE type, right, a course-based undergraduate research experience that would allow students in not only our Biomedical Technician Training program, but also our new partnership with Cheney University to really get involved in authentic research going on at Wistar. So Dr. Maureen Murphy studies the tumor suppressor P53, and she is particularly interested in hypomorphic variants of P53, including this African-centric S47 variant. So the wild type P53 amino acid sequence has a proline, and this variant that is more common in individuals of African, African-American, and Hispanic descent has a serine at position 47. So this change probably arose because it increased fitness in early humans, but in modern humans, it increases cancer risk. rather than focusing on why these individuals might be more prone to certain types of cancer, the Murphy Lab really focuses on more effective treatments. So developing personalized medicine. This paper was published in 2018, where the Murphy Lab showed that cisplatin, a very common chemotherapy, was actually more effective at killing cancer cells that have the S47 variant. And so it was a way to offer, a more effective chemotherapy treatment for individuals that do have this variant of the P53 gene. So Dr. Murphy has since done some screening, and so we have some hits that the students now follow up on to look for other drugs that may be more effective in killing the cancer cells with the variant, and then trying to figure out the mechanism by which that happens is what we can work on with the students through teaching these skills. So I will mention that one of the skills we added from the old 7-day format for the hands-on laboratory orientation was an ELISA, and that was based on industry feedback. And then we were able to increase the amount of time that students get to practice mammalian cell culture, which was also in response to both academic and industry lab demands. For those 20 years that Dr. Werner ran the Biomedical Technician Training program, the program was in 100 boxes in Wistar's basement that would come out from May to June for that 7-day orientation. So Wistar invested in a new training lab that we now have available to us year round. So we have beautiful space that we can set up so the students are working as they would at a bench as opposed to a classroom lab. We also have this built-in space. So rather than having the students do, classroom lectures, we can kind of interrupt the lab protocols and SOPs that they're working on with those quick mini lectures to provide some conceptual background, some theory to what we're doing. And then I said that increased cell culture. So we have our own cell culture room where we have 3 biosafety cabinets, 3 laminar flow hoods. So it's great to be able to have the students rotate from the main lab into that tissue culture room. I don't want to go over my time, so I don't want to leave Sandy without, but I think this group will be particularly interested in the fact that, Wistar is an academic research institution, and I haven't had industry experience. So I was really concerned about whether we were preparing students for industry. And it turns out in terms of what industry thinks is we might actually be doing a better job preparing them for industry than we are academia. So we can talk about those more, but some interesting results from the preliminary data this summer. And then, as I said, the Biomedical Technician Training Program can progress into a biomedical research technician apprenticeship, which was the first ever registered non-traditional biomedical research apprenticeship recognized by the Pennsylvania Department of Labor and Industry. So together, the BTT pre-apprenticeship program and the BRT apprenticeship provide participants with 2,000 hours of on-the-job training and 144 hours of related technical instruction, or RTI, as it's called in the workforce world, much of which can come from the prerequisite courses that they take before starting the hands-on biomedical technician training program. So hopefully, again, we'll have time to answer some questions after Sandy's presentation, but I am also happy to follow up with anybody by email.
Thanks, Kristy.